Middle of a linked list. Given the head of a singly linked list, return the middle node of it. If there's two middle nodes, take the second one. This is just kind of an exercise in linked lists. This isn't actually, you're not going to solve a problem like this in any sort of interviews. It's just to make sure you know what a linked list is and you have a little bit of an idea how to manipulate them. So you're given this first pointer and you want to say, okay, so if there's an odd number in this first example, you want this. If there's an even number, you want to find this. The basic logic is going to be you're going to use two pointers, a fast one and a slow one. In particular, the fast one is going to move twice as fast as the slow one. So by the time the fast one gets to the very end, the slow one will be in the middle somewhere because two moves at a time versus one. And generally with linked lists, when you do almost anything except for like working with the very beginning, it's going to be linear space. You're certainly never going to have a logarithmic space on a linked list. Now maybe, okay, if you do any sort of study of like parallel algorithms, they'll show you how to like, okay, if you have two arrays and you implement a linked list with a couple of arrays, you can sort of do some parallelization and get logarithmic span on things. But on this, it's an honest-to-goodness linked list with pointers and no contiguous memory or random access. So you're only looking at pretty much linear time for almost everything involved with them. Let's just go ahead and write it out. So you're going to have two pointers. You're going to have a list node slow, and we're going to set that equal to the head, and we're going to have a fast one. Fast equal to the head. The tricky bit about a problem like this is kind of like off by one errors. So you want to get, say, the second one if it's an even number, or instead of the first one. Yeah, that's mainly it. So, for example, if you wanted the first one instead of the second, you'd probably initialize this fast pointer to head's next, because the exit condition for our main loop is going to be, well, I'll show you. I'll talk about that in a minute. But it's going to be based on when fast becomes null. So if it becomes null a little sooner, then slow will be, not as far ahead. All right, so while we're only going to look at the fast is always going to be ahead, so fast is always going to be null before slow is, so while fast. And we have to check that first so that when we check fast, its next pointer, we're not going to look at this until we know that this is valid. So yeah, so since fast is moving two steps at a time, we do have to look ahead as opposed to just looking at what it currently is. So we're going to increment them. So fast equals fast, and we're going to move it two steps. Next, next. And then slow equals slow, next. And return slow. So that's going to be the one that's in the middle. One thing to note is our loop condition is always checking fast and fast next, but this could potentially make it, so both of these could be non-null, but then the next would be null, so fast could become that. And yeah, so I'll step through the example. We can do them both. So they're both initialized to this beginning. I guess I'll write it out. So we have slow and we have fast. So the first one, they start out both at 1. Fast, the first iteration, fast is going to move ahead by 2, so it goes to 3, and then slow is going to go to 2. Next iteration, fast is going to go to 3, 4, 5, 2 more ahead, 5, and then this is going to go to 3. And then our loop condition is going to see that 5's next pointer is null, so there is not going to be, there's no 2 steps ahead for fast to go. So there's 1 step ahead if you include this null pointer, but there's not a second one after that. So we're going to exit the loop and return. That's our even case. So that's our odd case. For our even number of nodes, all right, so they both start at 1. Same kind of deal. Fast jumps ahead by 2. Slow goes ahead by 1. and you just keep doing that. So 3, 4, 5, 3. And here's the case where, okay, we're at 5. If you include this like null value after 6, there are 2 spaces where fast can go. So fast is going to become null. So that, and then slow is going to still increment by 1 more, and we've got our second element. Now let's take a step back and we'll say, let's do an example of if we wanted the first one. So for this, we'd start fast at 2 instead of 1, so that's a little bit further ahead. It's going to hit the null sooner. Let's go ahead and see how that plays out. So 2 goes to 4, 1 goes to 2, and then 4, and then goes to 5, 6, and this goes to 3. Now 6, there's one null element after it, but there's not another. There's not 2 steps, so we have to stop here. This is the end of the loop. There's no 6 next. 6 next it's null. This is null. So we end here. Notice our slow pointer's at 3. So that's how you do it if you wanted the first one. But in this case, we just want the second one. And of course, it's 2 pointers. It's a loop. It goes through once, so it's going to be linear time. And we're just using a couple of pointers, so it's constant space as well. So it's O of n time and O of 1 space. And that's pretty much it. That's simple enough. I think let's go ahead and give it a run for syntax. Cool, and then we'll submit and then mark it off. Yeah, accepted. Middle of linked list. Thanks.